Hello everyone and welcome to the IT KnowledgeBase YouTube channel, your ultimate destination for IT tutorials, troubleshooting guides, and in-depth tech insights. Whether you are an IT expert looking for advanced solutions or a beginner seeking to build a solid foundation in information technology, we have got you covered. Our channel offers step-by-step guides, review of the latest tech trends, and practical tips to help you stay ahead in the ever-changing IT landscape. Subscribe for regular updates and never miss out on essential IT knowledge. Welcome to in-depth tutorial on setting up OpenVPN with multiple WAN connections using pfSense with dynamic routing and FRR free range routing. In this video lecture, we'll guide you through configure a robust VPN setup that enhances network security and ensures efficient routing across different WAN links. By integrating OpenVPN with OSPF, you can achieve dynamic route management, ensuring seamless connectivity and redundancy. Whether you are securing remote access or building site-to-site VPNs across complex networks, this setup provides the flexibility and resilience to your infrastructure needs. Let's get started. As a brief reminder, just master to be ready in pfSense. You can also watch my earlier comprehensive pfSense videos training where I have already covered various OpenVPN site-to-site VPN on a peer-to-peer shared key, SSL TLS, and IPsec tunnels. You can also configure site-to-site multi-site VPN, IPsec with IKEv2, external authentication with Active Directory or LDAP, site-to-site multi-site VPN between pfSense and OpenSense Firewall, and OpenVPN with external authentication with Microsoft Radius or NPS to establish VPN tunnels between your head office and the branches all around the globe. These all are the most stunning videos lectures, and if you want to be a pioneer and get all the adeptness in these valuable, I advise watching these videos. All the series links have been detailed in the description, so you can go through all this sequentially. Mark my words, after these mastered assorted training series, you will become a perfectionist and a completionist. I was simply inquisitive fixation mind about creating a site-to-site VPN configuration series, and I am particularly fond of demystifying the configuration of different types of VPN protocols so everyone can benefit from it. So you guys easily grasp all the required and essential configurations without any irritation and configure confidently in your production pfSense firewall to get your branches and mobile workers connected, protected, and secure your infrastructure. You can get the most experience in the VPN after getting this hefty training series. This is my present setup or a lab environment that I am covering today. OpenVPN setup with multiple WAN connections for high availability and configured OSPF routing protocol rather than using a regular OpenVPN routing approach. Set up a site-to-site OpenVPN instances on each WAN for the remote site using SSL TLS with a /30 subnet. If you don't know how to set up all these, then follow my earlier videos. OpenVPN quick and easy site-to-site VPN on peer-to-peer shared key and convert OpenVPN peer-to-peer shared key to peer-to-peer SSL TLS. I have already covered it with exceptional details, and you guys must watch this video and build your own lab along with all the prerequisites. In this video, I assume that we already have set up OpenVPN on peer-to-peer SSL TLS mode. Now let's talk about some clear points. Of multiple WAN for high availability with OSPF. Do not fill in the remote networks field on any of the server or client instances, only fill in tunnel network addresses. Set up two servers on the local side, each on a different WAN and port. Use two distinct non-overlapping tunnel networks, for example 10.31.50.0/30 and 10.31.56.0/30. Set up two clients on the remote firewall for testing the connectivity. Ensure these OpenVPN connections link up between client and server. The tunnel address on both sides will respond to a ping when they are working correctly, and appropriate firewall rules are in place. Ensure the OpenVPN firewall rules allow all traffic, or at least allow OSPF traffic from a sources of the tunnel network to a destination of any. The destination on the traffic will be a multicast address, which firewall rules can use to filter specifically if needed. But there is not much to be gained in the way of security if the source is locked down in the rules, as the traffic cannot leave that segment. Now check the prerequisites included. Create certificate authority and certificates for OpenVPN server and clients or branches. Then export certificate authority, branch office certificates and its private key to branch office. Configure OpenVPN server on the head office and an OpenVPN client on the branch office. Create client specific overrides. Create a WAN rule to open the OpenVPN port. And then create a OpenVPN rule to allow traffic. And I'll give you a glance at all the prerequisites. Okay, now I'll give you the comprehensive lab valuation, as I have already configured the OpenVPN peer-to-peer on SSL TLS mode. Let's straight the conversation back to the diagram and verify the settings. I have identically set up my lab as portrayed in the diagram. And now we are going to verify our WAN connections, tunnel networks, LAN networks, and other essential OpenVPN configurations. Let's switch over to my lab for a systematic review of network infrastructure and to understand the essentials of OpenVPN with multiple WAN configurations. In my head office, check the LAN side first. First log into the pfSense. I have assigned 10.0.20.0/24 to my LAN side and 10.0.20.1 is the IP address to my pfSense LAN interface. And I also have a one PC sitting behind the pfSense LAN with the IP address of 10.0.20.10/24. This is a Linux machine just for testing the side-to-side VPN tunnel and connection across the LAN. On the WAN side, I have dual WAN connection, primarily for higher availability for my OpenVPN side-to-side connection. Let's confirm the IP addresses from the pfSense dashboard. In the interfaces widget, check the IP address assigned to my WAN interfaces. As per diagram on my head office side, I have connected two WAN connections. The primary WAN IP is 192.168.11.180 and the secondary or WAN 2 IP address is 192.168.95.180. But before I move on to show you my OpenVPN with multi-WAN configuration, you must have fulfilled the prerequisites to establish an OpenVPN peer-to-peer SSL TLS configuration, server and client setup first. Certificate authority and branch certificates. It's imperative, go to System, Certificates. In the authorities, we require a certificate authority to establish a peer-to-peer SSL TLS connection. I have already created an S2S CA. Now click on Certificates. Here we need to create two certificates at least. One for the head office pfSense Firewall, as I have already created it as a server A. And second for the branch office. In this demonstration, I have only one branch office and I already created certificate name side B. And you could create more certificates for your other branches if you have. Now check the OpenVPN server configuration. Go to VPN, click on OpenVPN. As you can see, I have created two OpenVPN servers in the head office pfSense Firewall on WAN 1 and WAN 2 with different ports and different IP version 4 tunnel networks. This is essential for OpenVPN high availability. So to reiterate, the head office pfSense Firewall acts as a highly available OpenVPN server and is available to receive connections on multiple WAN interfaces. To ensure stable communication with the head office, branches should implement multiple connections pathways. Now let's edit and verify the configuration of each OpenVPN server. I have not configured anything special here. Click on Edit. Description is S2S WAN 1-BO or branch office. Server mode is peer-to-peer SSL TLS. Device mode is layer 3 tunnel mode. Protocol is UDP. Interface is WAN 1 and the port is default 1194. Leave everything default and keep scrolling down as everything has been configured previously. Check the IP version 4 tunnel network. IP version 4 tunnel network is 10.31.55.0/30 for WAN 1. IPv4 remote networks, which we are not providing here and leaving it empty purposely. Now scroll down all the way and click on Save. Now edit the second OpenVPN server, which will be working as our secondary or backup server. All the settings are the same except the interfaces, which should be selected on WAN 2. Server mode is peer-to-peer SSL TLS, device mode is L3 tunnel, protocol is UDP. All the settings are the same except the interface, which should be selected to WAN 2. The port is customized at 1195. Leave everything default and keep scrolling down as everything has been configured previously. In the IPv4 tunnel network, I have specified 10.31.56.0/30 for WAN 2 interface. And in the IPv4 remote networks, which we are not providing here and leaving it empty purposely, because we only wanted to establish a tunnel between the head office and branches, but not allowing routing through the tunnel. Scroll all the way down. If you have made any changes, then click on Save. Now click on the client-specific overrides. Make sure client-specific overrides is created for each client site. These tie a client subnet to a particular certificate so that OpenVPN can properly route a subnet to the correct site. Now check the WAN interfaces that should open ports to accept or allow OpenVPN connection request. Click on Firewall, click on Rules, and then click on WAN 1. WAN 1 is ready to accept OpenVPN connection on the port number 1194, which is the default OpenVPN port. Click on the WAN 2 and check the OpenVPN server port listing on WAN 2, and this is 1195 is also open. Now check the OpenVPN rule. Click on OpenVPN. Should explicitly allow all the traffic. This is the head office site configuration. Now let's switch and check all the prerequisites on the branch side. This is my branch office site pfSense firewall. To verify the prerequisites, let's start from the certificates. Click on the system, click on certificates, and in the authorities, I have imported the head office certificate authority. Now click on the certificates, and the branch office site certificate is also imported. Now let's review the OpenVPN peer-to-peer SSL TLS client configuration. But before that, let's steer the conversation back to the diagram and verify the settings. You have to verify all the WAN connections, LAN settings, LAN networks, IP addresses assignment on the WAN interfaces, tunnel networks, etc. Click on the dashboard. In my branch office site, check the LAN site first. I have assigned 172.16.16.0/24 network to my LAN site, and 172.16.16.1 is the IP address to my pfSense LAN interface. I also have a one PC sitting behind the pfSense LAN with the IP address of 172.16.16.10/24. Here it is. This is a Linux machine just for testing the site-to-site VPN tunnel and connection across the LAN. On the WAN side, I have a dual WAN connection, primarily for higher availability of my OpenVPN site-to-site connection. Let's confirm the IP addresses from the pfSense dashboard. In the interfaces widget, check the IP address assignment to my WAN interfaces. As per my diagram on my branch office site, I have connected two WAN connections. The primary WAN IP is 192.168.11.90 and the secondary or WAN 2 IP address is 192.168.95.190. Now check the OpenVPN client configuration. Go to VPN, click on OpenVPN, and click on the clients. As you can see, I have created two OpenVPN clients in the branch office pfSense firewall on WAN 1 and WAN 2 with different ports and different IP version 4 tunnel networks. This is essential for OpenVPN high availability. To ensure stable communication with the head office, branches should implement multiple connection pathways. Now let's edit and verify the configuration of each OpenVPN client. Click on Edit. The description is S2S WAN 1-HO, server mode peer-to-peer SSL TLS, device mode layer 3 tunnel mode, protocol is UDP, the interface is WAN 1 to originate this OpenVPN connection. Server host or address, this is the head office IP address of WAN 1. The server port is default on WAN 1. And now leave everything default and keep scrolling down as everything has been configured previously. In the IPv4 tunnel network is 10.31.50.0/30 for WAN 1 and IPv4 remote networks, which we are not providing here and leaving it empty purposely. Now scroll all the way down and click on save if we have made any changes. And now edit the second OpenVPN client connection, which will be working as our secondary or backup client. Click on edit. All the settings are same except the interfaces, which should be selected on WAN 2 and the port number. Server mode is peer-to-peer SSL TLS is fine. Device mode is layer 3 tunnel mode. Protocol is UDP. Interface should be your secondary WAN or WAN 2 and the IP address of your head office site WAN 2. Server port is 1195, which is customized. Scroll all the way down. Check the IPv4 tunnel network. This is 10.31.56.0/30 for WAN 2. IPv4 remote networks, which we are not providing here and leaving it empty purposely because we only wanted to establish a tunnel between the head office and branches, but not allow routing through the tunnel. We will use OSPF for establishing a routing between the head office and branches. This is a client side, so we don't need any configuration on the WAN interfaces. Now we only need an explicit rule to allow all the OpenVPN traffic. Click on Firewalls, click on Rules, and check the OpenVPN rule. OpenVPN rule is added and it's allowing all the traffic. This is the branch office site configuration. And of course, routing is still not established, and we will install and configure the FRR package and configure OSPF routing protocol. In the last, I would like to emphasize making sure both sides of tunnel interfaces are reachable before we move on to configure OSPF. Go to pfSense dashboard and note the IP addresses assigned on tunnel interfaces. I am on the branch side, so notice the tunnel IP addresses on WAN 1. The tunnel IP address is assigned as 10.31.55.2 and on WAN 2, the tunnel IP address is 10.31.56.2. How could you verify if it's reachable to head office site tunnel interfaces? Simply click on Diagnostics and then click on Ping. Now type the head office site tunnel IP address on WAN 1. It's 10.31.55.1. Select the source address. It should be OpenVPN client on WAN 1 and click on Ping. It should be reachable and yes, it's quick to respond. Now type the head office site tunnel IP address on WAN 2. It's 10.31.56.1. Select the source address, OpenVPN on WAN 2 and click on Ping. It should be reachable and yes, both tunnels are reachable to each other. Now go back to head office and repeat the same diagnostics on the tunnel interfaces. This is my head office site pfSense firewall. Now click on Diagnostics, click on Ping. Now type the branch office site tunnel IP assigned on WAN 1. It's 10.31.55.2. Select the source address, OpenVPN on WAN 1 and click on Ping. It should be reachable and yes, it's quick to respond. Now type the tunnel IP assigned on WAN 2. It's 10.31.56.2. Select the source address, OpenVPN on WAN 2 and click on Ping. It should be reachable and yes, both tunnels are reachable to each other. And here we have completed reviewing all the required prerequisites and settings which are essential to our OpenVPN peer-to-peer SSL TLS configuration. Now let's make our configuration more enticing. To install the FRR package and OSPF configuration, once both instances are connected, install the FRR package that includes and configure the OSPF. Click on the system, click on package manager and then click on available packages. In the search term, type FRR and click on the search button. Here is the latest package and then click on the install button. Click confirm and the package installation successfully completed. Once package is installed, navigate to services and click on FRR OSPF. And from here you have extensive OSPF configuration. Let's first discuss OSPF configuration. In the general options, check on enable OSPF routing. When checked, FRR will start the OSPF routing day 1 and attempt to use the OSPF settings in this section. Log adjacencies changes. When set, instructs the OSPF daemon to log changes in neighbor adjacency. This is useful for tracking changes to neighbor relationships, especially during initial configuration. Router ID, typically the highest number local address on the firewall. This is also frequently set as the internal or LAN side IP address of a router, and my LAN side IP of a router is 10.0.20.1. Leave SPF hold time, leave SPF delay as default. Enable SNMP agent X. This enables support for accessing FRR OSPF data via SNMP with the net SNMP package. Default area, type 0.0.0.0. This is my backbone router. Leave all the options as it is and click on save. Next, click on the areas, click on add. Area is a designation for the set of networks. Can be any number capable of being expressed in dotted quad notation or IPv4 address or as a 32-bit unsigned integer. The typical OSPF configuration is 4 times 0 is the backbone area between all routers, and each local network has its own area. For simpler deployments, the only area may be 4 times 0 on every router and interface. Using a single area disables some features such as route summarization. Description, type backbone. There are a lot of area type, but we will leave it to default. Scroll all the way down and click on save. Click again, type add. This time I would like to use 0.0.0.23 and this is for my local area network. Area type should be set to stub area. Scroll down a bit and type the route summarization. The option here can be repeated for multiple prefixes. Click add for each additional prefixes. My local network is 10.0.20.0/24. Do not advertise. This actually disables advertisement for the prefix. Cost, apply the specified cost to summarize routes for this prefix. Substitute prefix, leave it to default. This actually, instead of advertising the first prefix, it advertised this prefix instead. We will discuss all this information in my upcoming videos and click on save. Click on save again. Next tab is interfaces. Click add to create a new interface. The interfaces tab contains a list of current OSPF interfaces. OSPF must use one or more interfaces to announce itself to neighbors and to receive announcement from neighbors. At least one interface must be configured as active in order to locate neighbors and form an adjacency. In the interface, select LAN. It should be set to passive. In the areas tab, we have defined our LAN area is 0.0.0.23. Scroll all the way down. We don't need any authentication type right now. Leave it to default. There is no password right now. In the advanced tab, leave it to default. BFD, leave it to default and click on save. Now click add again. This time we would like to add our OpenVPN WAN 1 interface. Type description, OpenVPN WAN 1. Place a check mark on ignore MTU. A manual cost value to apply to this interface, allowing automatic cost calculation to take place. In situation where multiple paths are possible to the same destination, this allows OSPF to prefer one path over another when all else is equal. We have put a check mark on ignore MTU. This actually, if two neighbors are stuck in an X start state, this is typically from an MTU mismatch. If fixing the MTU mismatch is not viable, set this option on both sides. When present, OSPF will ignore the MTU advertised by neighbors and can still achieve a full adjacencies when pairs do not have matching MTU's value. This is my primary connection and I would prefer to write it to 10. Lowest metric value means higher priority. And the area of this should be 0.0.0.0, and then click on save. Now click on add, and this time add WAN number 2. Click on ignore MTU. This time matrix should be 20. This is my secondary connection, and area should be 0000. Now click on save, and then click on global settings. Navigate to global settings tab, place a check mark on enable, and type the master password. And this time I would write the password 123++. It is recommended to create a random string to use. Now click on save. Now repeat the same option on the branch office side. We are at our branch office. Click on the systems. Click on package manager to install the FRR package first. Type FRR, click search, click on installed, click confirm. Click on services, then click on OSPF. Okay, on the branch office side, everything should be identical as you have configured on your head office side. Click on enable. Router ID should be router's LAN interface. Default area is 0.0.0.0, and then click on save. Click on the area tab, click add. For our backbone area, it should be 0000. Description, type backbone. Leave all the settings as intact and click on save. Click add again, and this time we would like to add area for our local network. Description, type local area network. Set area type to stub area. Add the summary range or summary route. On the side V LAN network is 172.16.16.0/24, and click on save. Next, move on to next tab. It's interfaces tab. Click on add. Select LAN interface. Place a check mark on interface is passive. LAN area type is 0.0.0.23. Scroll all the way down and click on save. Then click add another interface. It should be WAN 1 or OpenVPN client WAN 1. Type OpenVPN WAN 1. Ignore MTU should be checked. Cost is 10 because this is a primary connection, and area should be backbone area, and then click on save. Add second WAN interface, WAN 2, description, WAN 2. Place a check mark on ignore MTU, and this time this is a secondary WAN interface, and this should be, the cost value should be set to 20, and the backbone area is 0.0.0.0, and then click on save. Click on save again. That's it. Now navigate to global settings, enable the FRR, and type the master password PASSW0RD123++, the same password that we have used in our head office. Make sure it's identical and click on save. Now navigate to status tab and confirm that the OSPF neighbor is present and its routes are in routing table. Click on status, click on OSPF, and then click on OSPF neighbors. And right now I'm at my branch office site, and my neighbor ID is 10.0.20.1. This is my neighbor on WAN 1, OpenVPN connection 1, and the tunnel interface IP is 10.31.55.2. The second OpenVPN tunnel interface is 10.31.56.2, and this also discovers the neighbor. So these two WAN interfaces has discovered their neighbor. Check the OSPF routes. In my branch office site, 172.16.16.0/24 is my local network, and the routed information OSPF router routing table has discovered the route from the OpenVPN connection 1. This is a route, and this is the detailed OSPF general information. And now let's check the OSPF interfaces. We have OSPF different interfaces. I'm at my branch office site. This is my area 0000. This is the backbone. OpenVPN connection on WAN 1 is up, and OpenVPN 2 on WAN 2 is also up. This is OSPF CPU usage details, OSPF memory. Now let's switch over to my head office. This is my head office site. Click on services or go to status. Click on FRR. In the OSPF, click on OSPF neighbor. From the head office site perspective, my neighbor is my branch office interface ID 172.16.16.1. This is my branch office site pfSense IP address of LAN interface, and this is the interface of OpenVPN 1 on my WAN 1 connection, and this is OpenVPN 2 connection. This is the OSPF routes. This is my local network route 10.0.20.0, and this is my branch office route. So my routing table are intact and it's fully updated. Click on the zebra, click on zebra routes, and here I would like to show you that the codes. O means OSPF. Now here you should see, if you have a previous experience of your network engineering, my pfSense is connected to these interfaces. This is the OSPF, and this is also an OSPF on WAN 1 and WAN 2. Okay, now test ping to my destination and trace path to check the tunnel interface, and then we will test the high availability. I am at my head office site, and before I test the high availability, I should check my routing with the branch office. Open the terminal, type ping space 172.16.16.10. This is the IP address of my branch office site Linux machine. Hit enter, and it's responding fine. Now check the trace path. Type trace path -n 172.16.16.10 and hit enter. And here we have to notice the tunnel IP address, which is 10.31.55.2. This tunnel IP subnet is assigned on my WAN 1 interface. We have successfully configured routing on OSPF in our head office and branch office site. Seems everything works perfectly, and now we should test the high availability. And I should disconnect the WAN 1, which is my primary connection, and then traffic should flow on my secondary connection, which is my WAN 2. Wait a moment. Now I have disconnected my WAN 1 connection. It should be 100% offline in a few seconds. I am pinging to my branch office Linux PC, and it's responding back. Now let's check the tunnel interface once again. Now this time traffic should flow from my secondary connection. Hit enter. And yes, notice the tunnel IP address. Before WAN 1 connection goes down, all the traffic was flowing on my WAN 1 connection, and the tunnel IP address was 10.31.55.2. And after the WAN 1 goes offline, all the traffic is flowing through my secondary connection, and the tunnel IP address of my WAN 2 connection is 10.31.56.2. Alright, that is all for the now. Thank you for watching, and I look forward to sharing more of my journey with you all. If you want to see more awesome training content, make sure you click that subscribe button. Click it so you don't miss it. Or if you have any issues or questions, you can reach out to me and I'd be happy to help you out. Thank you.